Hello, you're welcome once again to Maths Clinic series. My name is Evans O'Day. In this video, we are continuing the series of binary operation. And all this while we'll be looking at properties of binary operation and the commutative property. We've done associative property, and today we want to look at distributive property. What is distributive property? This is something that we know already because we've been doing it right from junior high school or middle school up to this particular stage. Now, when we talk of distributive property, from our previous lesson, if I give you A into bracket B plus C, and I ask you to expand and simplify this, we are going to do distributive property by just doing A multiplying B to give you AB and A multiplying C to give you AC. That is as simple as ABCD, right? Yeah. And so when we simplify this, and let me put a number into it and say, okay, maybe 3 into bracket 4 plus maybe 3, or no, let me use 2 here, and then it's equals to, now when I expand this, I'm going to have 3 times 4 plus 3 again times 2. Now here we are saying, what we are saying is that if we solve the left hand side and it's equal to the right hand side, then we can say multiplication that was used to distribute over addition. That is, what we learned from our previous lessons. And so here, if I do 4 plus 2, which is 6, here I can multiply this as 12 and I can multiply this as 6. If I multiply 3 times 6, which will give me 18, if I add this and this, I will get 18. So we can say multiplication is distributive over addition. That is possible. But could it be the same if I do addition distributive over multiplication? We'll look at that. But then in binary operation, what we are saying is that if I have two operations here, say operation star and operation triangle, and we define operation star and operation triangle, and we realize that, okay, and then we do something like operation star is distributive over operation triangle. This will be true if this statement here is true. Okay, so that we can say star is distributive over triangle. That means if I use this one to operate this, I'll get A operation B. If I use A to operate C, I'll get A operation C. But then we are distributing it over the operation triangle, right? And so if, let's say, star is multiplication and this is addition, and we're able to solve this and it is true like we did earlier on, then we can say star is distributive over addition. In other way around, if you go the reverse process and say, okay, let's see if addition can be distributive over multiplication. In that case, 2 plus 3 times 2 plus 5. And you can see that from the left hand side, 3 times 5 will give us 15, then plus 2. And here, this will give us 5, while this one gives us 7. If I add this one, which will give me 17, is not equal to the multiplication of this, that will give me 35. And so we are saying here that addition cannot be distributive over multiplication, but multiplication can be distributive over addition. Now let's see how we can apply this in solving questions in binary operation. Let's say you are given a question like this. If two binary operations, star and triangle, are defined as x star y is 2xy, s operation y is 2s plus 3y on the set of real numbers, okay, we want to show whether or not operation triangle is distributive over operation star, and we also want to test whether operation star is distributive over operation triangle. You can pause the video and try your hand on this. Right, now let's see how it goes. So we want to define this, that if the first one says operation triangle is distributive over operation star, that means I'm going to say operation, let's say x operation into bracket y operation z, and I'm going to distribute. So x will distribute to y here as x operation y, and then s again will pick that of the z to give you this. Then in between there we have our operation star. So we are going to simplify the left hand side and that of the right hand side and see if they are going to be the same based on the definition given to us in the question here. Okay, so first of all, we do the bracket first. So here we are going to maintain our x, okay, and then say y operation z goes with this part. And so according to the definition, it's going to be 2 times x times y. And so here is going to be 2 times y times z. Okay, we know binary operation from the onset. We've been doing this for some days now. If you've not watched the previous lesson from the beginning, I mean, you can check it on the YouTube channel, or you can go to the class and then pick it up. Now, everything here is equals to, on the part of this, we are looking at x operation y, and that comes to this part of the work, okay? That is x operation y, and by that definition, it is 2 times x plus 3y, and so that will give us 2 times x plus 3y. Then we bring our star, okay? Then this also, now here we are having x to represent x, while z to represent y, and by that definition, we're going to get 2 times x plus 3z as well. So we have this. Now let's continue. Now we are treating this as one entity, this whole thing as one entity, and we are dealing with x triangle operation 2yz. And so again, we come back to this portion of the work. And by that definition, we have 2 times the first number plus 2 times the second number, 3 times the second number. And so that will give us 2 times the first number plus 3 times the second number is equal to, here too, we are doing this star that, and that also comes to the portion here where we have 2 times the first times the second, and so 2 times the first times the second. So we are going to simplify the left hand side and the right hand side. The left hand side is going to give us 2x plus 6yz. The right hand side, if I multiply through 2 by this, I'm going to have this. Then I'll repeat this one, and then let me repeat the left hand side because that one I can't do much about it. But I'm going to expand and simplify this. You can pause the video and do that and see. If you do the expansion and simplification, you end up getting this as your answer there. And it's obvious that the left hand side is not equal to the right hand side. And so our conclusion is that since the left hand side is not equal to the right hand side, then we'll say that the operation triangle is not distributive over operation star. For this very question, operation triangle is not distributive over operation star. Let's look at the other way around, the B part, which says that we should also determine whether operation star will be distributive over operation triangle. So the same thing, we now going to have our operation star rather going to distribute. So it will be S operation Y, that is this one, triangle S operation Z, and that is that one. So on the left hand side, I'll do the bracket first. So I'll maintain my X star into bracket. I'm doing Y operation Z, and Y operation Z will go by this, which is 2 times the first plus 3 times the second. 2 times the first plus 3 times the second is equal to, now I'm doing X operation Y, and S operation Y also goes by this approach, which is 2 times the first times the second. So 2 times the first times the second. Then I'll bring my triangle. The same thing for X operation Z, 2 times the first times the second. Good. Now this is where I'm putting to. Now I'm treating this as one entity, and I'm keeping this also as another entity. So this will represent my X, and the whole of this will represent my Y in the definition that we have there. Okay, so now we are dealing with this one now. We're dealing with this one now. So according to the definition there, it is 2 times the first times the second. Okay, it's equal to, now when I come to the right hand side here and I'm dealing with this part of the equation, according to the definition of the triangle, it should be 2 times the first plus 3 times the second. So 2 times the first plus 3 times the second. Then I'm going to simplify both left and right. So for the left hand side, when I expand this, I have 4xy plus 6xz. And here too, if I multiply this by this, I'm going to get 4xy. Okay. And when I multiply this by this, I'm going to get 6xz. And here you can see obviously that the left hand side is equal to the right hand side. And so what is the conclusion? So left hand side is equal to the right hand side. So the conclusion is that operation star is distributive over operation triangle in the context of this question. So for the A part, we saw that it wasn't true, but the B part, operation star rather can distribute over operation triangle. So to conclude, I will give you one assignment to do for me. Try your hand on this. Given that operation triangle and operation addition symbol, and here it's not just plus, it's a symbol. Okay, so operation triangle and operation this, operation addition are binary operations defined on a set X. Okay, so S is XYZ, that's the set involved. And so determine whether or not star will be distributive over plus. And I've given you the equation here. So take your time and do the left hand side and the right hand side and see if you are going to get the same answer. But then this question actually, the plus represent plus for the sake of this equation. So I think it will go for that. So try your hand on this and let's see how it will go. Thank you so much for watching this lesson. Stay blessed.